So we have a problem. It is given that the angle theta satisfies the equation this. Find the value of tan 2 theta. And we've broken down what we've been given, and we now are looking at what we know. We know these equations here. We also know that tan theta is sine theta over cos theta. That one's quite a fundamental concept as to what the tan actually is representing in this situation. By the way, if this is tan 2 theta, then the alpha and beta are both theta. So this would be theta plus theta, which is 2 theta. And in these circumstances, then the angle, this alpha here, this angle alpha, and the angle beta are equal. That's to what the 2 theta represents. When these two angles are equal in size, and again, you've got this right angle triangle here. Imagine alpha and beta are equal. Tan represents the opposite divided by the adjacent. But particularly, before we look at that, we'll come to that later, tan theta is mainly born from sine theta over cos theta. That's one of the most fundamental concepts. And what I've got here is I've got sine theta here, there's sine theta, and I've got cos theta here in blue. And I want you to notice a couple of things about this. First of all, let's go for the most obvious. When sine theta, let's look at this position here, this position there. When sine theta is 1, so this value here would be 1, cos theta, and this is the angle for half pi, which is 90 degrees, cos theta, so cos 90 would be 0. So this would be, when it comes to 90 degrees, half pi, sine is 1, as you can see at the top here, there, sine is 1, but cos is 0. So you'd have 1 divided by 0, so it'd be infinity. And if you look at the graph for tan, you can see at 90 degrees, tan is going up to infinity here. There is no value there. Another thing to be aware of is this situation here. Let's look at this one here again with tan theta. So if you look at tan here, well, what is this? This is 1/4 pi, so 45 degrees. Sine 45 is root 2 over 2. Sine 45 is root 2 over 2. And that's about 0.7, so 1.4 divided by 2. And cos 45 is the same, it's root 2 over 2, which is why they're both overlapping at this point. Now, if I had root 2 over 2 divided by root 2 over 2, that's the same thing divided by the same thing, I'd get 1. And so again, so at 45 degrees, tan is 1. So tan is mapping out the values when you take cos and sine, and you do sine divided by cos. That's why tan looks like this. And just to be reminded, this is the equation of tan, sine theta over cos theta. Next stage, next thing to recognize. We know sine theta is opposite divided by hypotenuse, and cos theta is adjacent divided by hypotenuse. I can substitute these in and get OH divided by, this should be AH in here, I do apologize. This should say AH. So I put a little A in there, probably made things worse. Let me just put it to the side so you're aware. So this is opposite divided by hypotenuse divided by adjacent divided by hypotenuse. Bit of algebra. It depends what techniques you're comfortable with. You can think of it as the top, bottom, bottom, top. So at the top you'd have opposite. At the bottom you have hypotenuse. At the top you'd have adjacent. At the bottom, sorry, you'd have adjacent. And at the top you'd have hypotenuse. The hypotenuse will cancel. I'll write this out so it's made a little bit clearer here. Like my mouse. There you go. So what you'd have is you'd have a situation wherein if you consider that at the top you'd have an opposite, at the bottom you'd have hypotenuse, this is adjacent, this should be, so at the bottom again you'd have adjacent, and at the top here you'd have hypotenuse. So that's when you have this type of 4-part fraction as you have depicted in this circumstances. And so what you'd notice then is the hypotenuse will cancel. So this would cancel with this, leaving you with purely opposite over adjacent. And that leads us to our last thing that we know, or not the last thing, but one thing that we know that might also be advantageous, which is that tan theta is the opposite divided by adjacent. As I described when looking at this triangle, I said it's the opposite part of the triangle divided by the adjacent part of the triangle. It is that ratio that we're dealing with. So we now have we now have everything we need. We know that tan theta is opposite over adjacent. We know the sine and cos. We are aware of the relationship between tan, sine and cos. We know even what they look like at certain points and certain angles, which we might need at some point. And finally, we have our double angle formula. This one here has been proven in past videos. If you do the same techniques for that proof, but for adjacent divided by hypotenuse, you'd end up with this. If you do the same techniques in that, but instead you do for opposite over adjacent, you'd end up with this. Now let's go straight to the problem. The problem is sine 2 theta plus pi over 4 equals 3 cos 2 theta plus pi over 4. The first thing I want to utilize is this. The sine over cos will give us the tan. The question wants us to have it in terms of tan. So why don't we divide both sides by cos? And so what I'm going to do, the first thing I'm going to do is divide both sides by cos, as I've just stated here, and it would be sine 2 theta plus 3 or plus pi over 4 over cos 2 theta plus pi over 4 equals 3. And so at this stage, we are now closer because I can state very comfortably that we know sine theta over cos theta is tan theta. So rather than having sine and cos, I'm just going to have tan. And so we're left in a good position for our next conversation with this situation. Tan 2 theta plus pi over 4 equals 3. And I think we're slightly closer to our situation because now we've got rid of sine and cos and we're in tan. We now just need to get tan 2 theta on its own, which we shall tackle in the next video.